is the executive summary dashboard. It provides a high-level overview of the renewable energy forecasting system, showing the current estimated generation, forecast accuracy, remaining forecast for today, pipeline health, and last refresh information. So the current solar estimate. This KPI displays the current estimated solar power generation in megawatts. So current wind estimates the current estimated wind power generation in megawatts. So the solar wave based score. This card represents the forecasting accuracy of the solar model using wave matrix and wind wave based score. This card shows the forecasting accuracy of wind predicted model. In our dashboard, the wind model achieves the higher accuracy score compared to the solar model. So remaining today forecast. A line chart shows remaining forecasted energy generation for the rest of the current day. The x-axis represents the forecasted time and the y-axis represents the forecasted power in megawatts. The chart also compares solar and wind generation throughout the remaining hours. So the web-based score by technology, the bar chart compares forecasting accuracy between solar PV and wind turbine technologies. It helps to identify which forecasting model performs better. So the last pipeline status, this KPI indicates whether the end-to-end data pipeline executed successfully. A success status confirms the data ingestion, pre-processing, forecasting, and dashboard refresh completed without errors. So in this page, the dashboard focuses on operational monitoring of renewable energy forecast. It enables operators to analyze forecasts across different datasets, forecast horizons, and time periods. So within this slices, we have three slices. That is, the first one is dataset. Here we can filter through the dataset. Like if we select solar, then the dashboard only shows about the solar dataset. Similarly through window, here we can see we can select the date and we can select which part. So the next is, in this forecast stores, this KPI shows the total number of forecast records generated during the latest forecasting cycle, and the production model version. This displays the current deployed machine learning model version. It provides in complete model traceable and support model. So the operational generation forecast. This line chart displays forecasted solar and wind generation over multiple future time periods. It provides an operational view of expected renewable energy forecast by horizon. This chart visualizes forecasted generation at different forecast horizons. It helps to evaluate how predictions change as the forecasting horizon increases. So the solar generation forecast. This chart focuses exclusively on solar generation trends across the forecast period, and the wind forecast. This chart presents forecasted wind generation separately, allowing detailed analytics of the behavior. So forecast analysis dashboard. This dashboard explains how weather conditions influence renewable energy forecast. It combines weather parameters with forecasted power generation to support decision making. So, the wind speed versus forecasted generation. This scatter plot analyzes the relationship between wind speed and forecasted power generation. It helps to understand how changes in wind speed influence the renewable energy output. The cloud cover versus forecasted generation. This scatter plots illustrates the relationship between cloud cover and forecasted generation. The higher cloud cover generally corresponds to lower solar generation. Weather aware forecast details. This detailed table combines forecast rate values with temperature, wind speed, cloud cover, forecast horizon, and a model information. It provides complete transparency into each forecast record. The generation forecast under weather condition. This line chart visualizes the forecasted generation while considering weather condition. It all helps to identify how weather variation affect future solar and wind power production. And the last, model performance and validation dashboard. This dashboard evaluates the performance of the forecasting models by comparing against actual historical data generation. So the mean absolute error, it's the measure of average prediction error between log actual and forecasted generation. Actual average actual generation. This KPI displays the average historical power generation recorded from the renewable energy. The average forecasted generation. This KPI displays the average generation predicted by the forecasting model. Actual versus forecasted generation. This line chart compares actual generation with the forecasted generation over time. The close both sir both lines are the better forecasting model performance. The absolute error over time. This chart displays the prediction error over time. It helps to identify periods where forecasting error increases, allow future model improvements. I created a chat GPT style interaction layer for the energy forecast pilot. A user can type questions in normal English without writing SQL, Python, or Spark code. The backend maintains conversation messages and connects user questions to the forecasting and retrieval logic. This makes technically forecasting information more accessible to operators, analysts, and decision makers. So, in my Copilot, I just typed the question, what is tomorrow's expected generation? So the Copilot replied that for 14th July 2026, that is tomorrow, from the source gold future generation forecast, so the solar average power generated will be 5.68 megawatt, and at peak the power generated through the solar will be 20.01 megawatt, and the minimum will be 0 megawatt. While through wind the average of 0.34 megawatt will be generated with the peak of 0.55 megawatt and with the minimum of 0.136 megawatt. So this forecast window will be run through 11:30 a.m. to the next day 8:30 p.m. So the next question was why was generation dropping? So for this, a short answer was the drop is driven by reductions in the solar forecast and coincide with high cloud cover impact. So similarly, I have also typed some more question where we can see here what is the tomorrow expected solar generation. So here we can say average expected solar generation tomorrow is 5.687 megawatt. So this is how my chatbot works. So here user can type their questions.